Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As we all know, my name is Tutor Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. Before I get started, before I jump into today's topic, I want to say a very big thank you to those who have subscribed my YouTube channel. Please, as for those who are yet to do so, I'm begging, please subscribe, like, share, and comment. If you have friends who are science students who are preparing for different examinations, please endeavor to share the link so that they will also subscribe and they will keep sharing. All right, so please take note of that. Please comment, like, share, and subscribe. Very, very important. In today's topic, we shall be discussing nitrogen cycle. Before I go into this topic, let me quickly do a little introduction to just nitrogen as a diatomic element. Now, nitrogen is found in the atmosphere as what? As an unreactive gas, because it is found in the atmosphere, reducing the process of, it prevents combustion and reduces what? Corrosion. And therefore you say it acts as what? Diluent. It is diluent because it prevents combustion and reduces what? Corrosion. Take note of that. Nitrogen is found in the atmosphere because it is what? Unreactive. Now, what is the meaning of nitrogen cycle? Okay, it is a complex process in which nitrogen is naturally added into the soil through lightning or thunderstorm, or it is removed from the soil by certain bacteria. Okay, now that is through a process called denitrification. I will take it again. Nitrogen cycle is a complex process in which nitrogen is naturally added to the soil through lightning or thunderstorm, or it is removed from the soil. Okay, now when it's removed from the soil, you say it is what? It has undergone denitrification, and it does not happen just by itself. Bacteria are responsible for that. The azotobacter and the clostridiums are denitrifying bacteria in the sense that they remove nitrate from the soil and convert it back to what? Atmospheric nitrogen. That is the meaning of what? Nitrogen cycle. It's a complex process where nitrogen is fixed into the soil naturally, or it is removed from the soil. It is a sequential reaction. It is actually sequential, in which nitrogen is added to the soil and it is removed from the soil, just like that. Now, take note that this cycle is not complete outside the process of nitrification and what? Denitrification. Okay? Now, when nitrogen is fixed into the soil, you call that what? Nitrification. But when it is removed from the soil, you call that what? Denitrification. Take note of that. Now, what are the different terms associated with this cycle, nitrogen cycle? Please let me check. Yes, it's recording. What are the different terms associated with nitrogen cycle? What are the different terms? All right, you have number one, symbiotic nitrogen what? Fixation. All right, the mutualistic relationship between two organisms called symbiotes, you call that what? Symbiotic feeding association. So symbiotic nitrogen fixation occurs in bacteria that are found in the root nodules of what? Leguminous plants. All right, there are some bacteria that are found in the root nodules. They have the ability to fix what? Atmospheric nitrogen into the soil as what? Nitrates. It is mutualistic because the root nodules provides shelter for the bacteria. The bacteria provides nutrients in the form of nitrates to the roots of the plant. You know that when the root of plant absorbs nitrates, protein is what? Produced. Secondly, when animals feed on plants, indirectly they will feed on what? Nitrate to produce what? Protein as well. What are the examples of bacteria that are symbiotic, in the sense that they have the ability to fix atmospheric nitrogen into the soil as what? Nitrates. You have it to be Rhizobium leguminoserium. Rhizobium leguminoserium is symbiotic and is found in the root nodules of leguminous plants. Take note of that. Number 2 is what? Non-symbiotic nitrogen fixation. All right, there are some bacteria that are found living freely in the soil. They are found living freely in the soil. It means that they do not have a symbiotic association. Okay, they can by themselves fix atmospheric nitrogen as nitrates in the soil because they possess an enzyme called what? Nitrogenase. They are able to fix atmospheric nitrogen by themselves because they have an enzyme called what? Nitrogenase. They are found living in the soil freely. They are just found there living freely, and they can actually fix atmospheric nitrogen into the soil as what? Nitrates, because they possess an enzyme called what? Nitrogenase. What are these examples of organisms? We have the Azotobacter, we have the Clostridium, we have the Nostoc species, we have the Anabaena species, you have the Bacillus, which is a rod-shaped bacteria. You have a Azospirillum. All right, Azospirillum, Azoacus. All of these are examples of what? Hope Azotobacter is there, Clostridium there. So good. Serratia, Pseudomonas. All of these are examples of what? Non-symbiotic nitrogen fixing bacteria. All right, they are just found living freely in the soil. They possess an enzyme called what? Nitrogenase. Of course, you agree with me that Nostoc and Anabaena are called what? Cyanobacteria. They are called cyanobacteria. All right, they have the ability to fix both nitrogen and what? Oxygen. Take note of that. Number three, we have what is called electrical discharge. Electrical what? Discharge. All right, during lightning or thunderstorm, what happens? Atmospheric nitrogen will react with oxygen to produce what? Nitrogen 2 oxide. I'll balance the equation by just adding 2 here to produce what? Nitrogen 2 oxide. I said atmospheric nitrogen will react with what? Oxygen to produce what? Nitrogen 2 oxide. It does not stop there. This NO produced further react with oxygen to produce what? HNO2. Is that equation balanced? No. So I'll put 2 at the back of this place, then 2 at the back of this place. Now what I've just produced, this guy is the nitrite. We've been saying. So please, when during lightning or thunderstorm, nitrogen react with oxygen to produce NO. This NO react with oxygen to produce what? HNO2, which is what? A nitrate. Now this nitrate produced, it undergoes oxidation. All right, it undergoes oxidation. Oh no. Oh no. This is a very big mistake. No, it cannot happen in my time. Sorry. As soon as this NO is reacted with oxygen, all right, it forms NO2. Sorry, that was a mistake. Thank God I realized that quickly. All right, it forms what? NO2, which is a mixed acid anhydride. Okay, the equation isn't balanced. I'll put 2 here, then 2. As soon as this NO2, which is called nitrogen 4 oxide, is produced, it reacts with water. It reacts with water to form HNO2 and what? HNO3. This is nitrites and this one is what? Nitrates. You see that? So I think I'll put 2 here. Is that correct? Yeah. So the equation is balanced. What I've just done is what? The reactions to show electrical what? Discharge. During lightning or thunderstorm, atmospheric nitrogen reacts with oxygen to produce what? NO. That is nitrogen 2 oxide. This NO is reacted with oxygen to produce what? Nitrogen 4 oxide. Being a mixed acid and hydride, it reacts with water to form 2 acids, NO2 and HNO2 and HNO3. Please, plants do not absorb nitrites. Neither do they absorb nitrogen. They only absorb nitrate. It is nitrates they make use of for good growth and healthy development. Take note of that. Then number 5, okay, I'm too fast. Number 4, you have nitrification. The process by which atmospheric nitrogen is fixed into the soil is called what? Nitrification. Examples are Nitrosomonas and Nitrobacter. Nitrosomonas and Nitrobacter are what? Nitrifying bacteria, because they are able to convert atmospheric nitrogen into what? Nitrates in the soil. Number 5, you have denitrification, that is the opposite of it, in which nitrate is converted back to atmospheric what? Nitrogen. Examples are Azotobacter and even Clostridium. Azotobacter, Clostridium are what? Denitrifying bacteria, because they are able to convert the nitrate present in the soil back to what? Atmospheric nitrogen. The 6th one, you have ammonification. These are different terms associated with what? Nitrogen cycle. Ammonification is a phenomenon characterized by the formation of ammonium compounds. The formation of what? Ammonium compounds from dead and decaying organic matters such as plants and animals. And they are also formed from urine and what? Physics. So please, these are different terms associated with nitrogen cycle. Okay, good. You also have another one, the 7th one, called putrefaction. When decomposing agents such as fungi and bacteria break down larger molecules into simpler ones. Now, once a leaf, okay, the rotting of leaves or the decaying of leaves, you simply call it what? Putrefaction. And the decaying or decomposition of leaves is brought about by fungus and what? Bacterium. Take note of that. So putrefaction, ammonification, denitrification, nitrification, electrical discharge, non-symbiotic nitrogen fixation, and symbiotic nitrogen fixation are terms associated with what? Nitrogen cycle. So please take note of this. I'm going to run it off by giving us the cycle. I'm not stopping here right now. Okay, I've given us the various terms, but it is also important we look at the cyclic shape of the cycle, right? The cyclic nature of this. Okay, I believe I can rub it off. Okay, let me give us just, hope it's recording. Yeah, it's recording. So let me give us few minutes, just go through it. Symbiotic, non-symbiotic, electrical discharge, nitrification. Take note of the examples. All right, so let's go. Let's use a diagram to illustrate nitrogen cycle. It is very, very easy. All right, just focus. You understand it very, very well. This board is somehow. So let's get started. So I'll write here atmospheric atmospheric nitrogen. All right, atmospheric nitrogen. Then I'll write here ammonium compounds. I'll just put NH4 minus. All right, let's get started. Now these ammonium compounds are converted to what? Nitrate. Sorry, not nitrate. No. They are converted to what? Nitrite by nitrosomonas, right? Through what process? Nitrification. Through nitrification process, ammonium compounds are converted to what? Nitrite, which is what? HNO2. HNO2. Now this nitrite formed is converted to what? Nitrate. Nitrate. And nitrate is what? HNO3. I told you guys that this idiot, this HNO3 would undergo what? Oxidation. Alright? For nitrite to be converted to nitrates, and there's a bacteria that also take part called what? Nitrobacter, as given us before, or as given before, Nitrobacter. So Nitrobacter is that bacterium that converts nitrite to nitrate, but nitrosomonas convert ammonium compounds to what? Nitrite. Look at the reaction here. You have HNO3 reacting with oxygen to form what? HNO2 plus what? Water. Plus water. Is the equation balanced? Okay. I should put 2 here. Should I put the 2 here or? Okay. Alright, so that is 3. I should put 2 here. How many nitrogen? Okay. I have 2 nitrogen. I have 6, so I'll put 2 here. So is it balanced now? 2 nitrogen, right? So I'll put 2 here. So let's see if the equation is balanced. 2 nitrogen, 2 nitrogen. Oxygen, you have 4, and here you have 2. That is 6. Then how many oxygen? 2 times, how many hydrogen? 2 times 3 is what? 6. Alright. 2 times 2, 4 plus 2, 6. So you see now that this compound is converted to what? This nitrite. This is nitrite. Now this nitrite would undergo oxidation. Look at it here. HNO2. It will form what? HNO3. Don't forget energy is also formed. Energy. Alright, so then plus energy. Is the equation balanced? So how many? Okay. Put 2 here, put 2 here. Alright. 2 times 2, 4. 6. 2 hydrogen, 2 nitrogen, 2 hydrogen. Okay, so it is balanced. So this one is what? Nitrate. You can see that. So nitrate is formed when nitrite initially produced undergoes what? Oxidation to produce this. Now this nitrate produced is absorbed by plants. All right, it's absorbed by plants, and animals as well. Animals would feed on plants. Animals would feed on what? Plants. Now this nitrate is converted to what? Atmospheric nitrogen through what? Denitrification. All right, as given before. What is that bacteria involved in it? You have the Azotobacter and what? Clostridium. Azotobacter, Clostridium are denitrifying bacteria. Now this same atmospheric nitrogen present here is converted to nitrates through what? Electrical discharge. Electrical what? Discharge. You see, it is very easy. Just follow it bit by bit. Okay. I also told you that during putrefaction. This reaction. Okay, let me just do it like this. Let me do it like this. All right. I told you that ammonium compounds are formed through what? Ammonification from where? Dead and decaying organic matters. So which means that I'll just write here, excuse me, sorry, permit me, I'll write here putrefaction from dead and decaying matter. From dead and decaying what? Matter. Alright, you can just write somewhere here physics and what? Urine. Physics and what? Urine. Okay. Now, you know that plants would absorb nitrates to produce what? Protein. We also agree with me that bacteria in the roots nodules of plants can also fix atmospheric nitrogen into the soil as what? Nitrate. As given before, you have the Rhizobium leguminoserium. All right, so please take note of that. All right, for you to give a short pictorial view, you can just draw a tree here, tree of any sorts. Okay. All right. All right, you know the root of plant will absorb nitrates. Okay, and you can also draw something like Rhizobium root here. Alright, so this is the root of a leguminous plant. Now this is the nodules where the bacteria are found. Alright, so take note of that. So at this point, we'll call it a day. Please, if you know you haven't subscribed to my YouTube channel, do that, because it will also help you in the sense that whenever I upload a new content, YouTube will immediately give you a notification that Joseph has uploaded a new content. It is very, very good you subscribe. Thanks for doing that. So at this point, we call it a day. So what I've just illustrated is what? A nitrogen cycle. Do have a wonderful day.